Docker is an open platform for developing, shipping, and running applications. It helps you separate your infrastructure from your application and lets you ship, deploy, and run applications very quickly. Docker provides something called containers, which are isolated environments that contain all of the dependencies for a particular project. Containers are similar to virtual machines, but are much more lightweight and flexible, and can usually be started in a matter of seconds as opposed to minutes with virtual machines. When you use a Docker container, you no longer need to rely on the setup of the host machine. Any dependencies that your container needs will be installed automatically in an isolated environment for you. So Docker is very popular for CI and CD and is helpful when you want to let anyone run your application quickly, regardless of their host operating system and their pre-existing setup. So now that we have a basic understanding between Docker and virtual machines, because they are similar in some ways and sometimes they do accomplish the same tasks. So virtual machines are simply instances of an entire operating system that's running on the hardware of a single machine. So you may have, say, 4 virtual machines running on one physical machine that you have. Now, these are isolated environments that are running an entire operating system. So virtual machines are managed by something called a hypervisor, and they utilize a lot of memory, CPU, and other system resources. Now, this is because they're running an entire operating system, and that OS requires RAM, disk space, CPU, etc. Now, Docker is different because it uses something called containers that on a low level are simply processes running in an isolated environment and sharing the host operating system. So rather than having a bunch of virtual machines with their own entire operating system, you have a bunch of Docker containers that are relying on the same host operating system, but still are able to run different applications and have their own isolated environment. Now, compared to virtual machines, Docker containers are much smaller in size, they take up less system resources, and can be started very quickly.
We're going to talk about Terraform. First, I'm going to explain to you what Terraform is and what it's used for. Then we will see what is the difference between Terraform and Ansible and when to use each. Terraform. Terraform allows you to automate and manage your infrastructure and your platform and services that run on that infrastructure. It's open source and it uses declarative language, meaning you don't have to define every step of how this automation and management is done. You just declare what you want, the final result or end result, and Terraform will figure out how to execute it. Infrastructure provisioning. So what does that mean exactly? Let's say you just started a project where you create some application and you want to set up an infrastructure from scratch where this application will run. How does your infrastructure look like? Let's say you want to spin up several servers where you will deploy your 5 microservice applications that make up your application as Docker containers, and also you're gonna deploy a database container. You decide to use AWS platform to build your whole infrastructure on. So first step will be to go to AWS and prepare the setup so the applications can be deployed there. This means you create your private network space, you create and deploy EC2 server instances, you install Docker on each one of those, plus any other tools that you might need for your application. You set up security on your servers, like firewalls, you set up network, etc. Once the infrastructure is prepared, you can now deploy your Docker applications or Docker containers on that prepared infrastructure. So as you see, these are 2 different tasks or 2 separate steps of creating the whole setup. One is provisioning the infrastructure, preparing everything so the application can be deployed. And the second one is actually deploying the applications on it. So you might even have 2 separate teams or 2 individuals who do these 2 separate tasks. So possible scenario, a DevOps team member configures the infrastructure and a developer then deploys the applications on the prepared infrastructure. So where does Terraform come into this whole thing? Terraform is used for the first part, where you provision the infrastructure to prepare it for the application deployment. Creating the VPC, spinning up the servers, creating the security, the AWS user with its permissions, maybe installing Docker specific version on servers, etc. And obviously all of this needs to be done in a correct order because one task maybe depends on the other. Now here I must mention something that a lot of people ask when it comes to Terraform. Let's see the similarities and differences between these two, using our example setup. First of all, Terraform and Ansible are both infrastructure as a code, meaning they're both used to automate provisioning, configuring, and managing the infrastructure. However, Terraform is mainly infrastructure provisioning tool. That's where its main power lies. But it also has possibilities to deploy applications and other tools on that infrastructure. Ansible, on the other hand, is mainly a configuration tool. So once the infrastructure is provisioned and it's there, Ansible can now be used to configure it and deploy applications, install and update software on that infrastructure, etc. So as you see, there are overlaps of what each tool does, and this creates the confusion. Other differences to consider in terms of those overlaps are Ansible is more mature and Terraform is relatively new, and because of that, it's also changing dynamically. And Terraform is much more advanced in orchestration. So to summarize the difference, Terraform is a better tool for provisioning infrastructure, and Ansible is a better tool for configuring that infrastructure, deploying, installing applications and services on them. So it's a common practice where DevOps engineers use the combination of these tools to cover the whole setup end to end, using both for their own strength, instead of just using one tool. The infrastructure as a code tools like Ansible, Chef, Terraform, CloudFormation, etc. in more detail, and also explain why each is best in one area, even though they can do other tasks as well.
Compute instances, storage, networking, but also things such as DNS entries, web application firewalls, and edge compute functions. The sky is the limit. Terraform offers a ton of different providers that can be used to manage your infrastructure easily.
Today we're going to take a look at a tool called Pulumi.
What is Pulumi? Pulumi is a modern infrastructure as code (IaaC) platform that allows developers and DevOps teams to define and manage cloud infrastructure using familiar programming languages such as TypeScript, Python, Go, and .NET. How does Pulumi work? Pulumi works by providing a set of libraries and tools that allow developers to define and manage cloud infrastructure using familiar programming languages. Language support. Pulumi supports several popular programming languages, including TypeScript, Python, Go, and .NET. Developers can use these languages to write infrastructure code that defines the desired state of their cloud resources. Resource providers. Pulumi provides a set of resource providers that allow users to define infrastructure resources in code. These providers include AWS, Azure, Google Cloud Platform, and many others. Declarative programming model. Pulumi uses a declarative programming model, where users define the desired state of their infrastructure resources in code. Pulumi then applies the necessary changes to achieve that state, rather than requiring users to write imperative scripts that define how to make those changes. Continuous delivery. Pulumi integrates with popular C/CD tools such as GitLab, GitHub Actions, and Jenkins, allowing users to automate their infrastructure deployment and management workflows. Cross-cloud compatibility. Pulumi supports multiple cloud providers, allowing users to define infrastructure that spans multiple cloud environments. Overall, Pulumi's approach to infrastructure as code provides several benefits, including improved developer productivity, increased visibility and control, and better infrastructure reliability and consistency.